people get demoralized if they don't see the result of their work much sooner. Give it weeks, maybe months. If that amount of time passed and you don't see the result of what you're working, but it's just in some ephemeral state nobody can recognize, you're going to get demoralized. I get demoralized.
This is DevOps Paradox, episode number 262, Rethinking Project Success the Iterative Way. This episode of DevOps Paradox is brought to you by Barbaro Moho. Welcome to DevOps Paradox. This is a podcast about random stuff in which we, Darin and Viktor, pretend we know what we're talking about. Most of the time, we mask our ignorance by putting the word DevOps everywhere we can and mix it with random buzzwords like Kubernetes, serverless, CI/CD, team productivity, islands of happiness, and other fancy expressions that make us sound like we know what we're doing. Occasionally, we invite guests who do know something, but we do not do that often since they might make us look incompetent. The truth is out there, and there is no way we are going to find it. P.S. It's Darin reading this text and feeling embarrassed that Viktor made me do it. Here are your hosts, Darin Pope and Viktor Farsic. Viktor, how long has it been since you've started working on a Greenfield project?
Like a real Greenfield project that goes to production and used by many people, or Greenfield project like I want to see whether this is useful for something?
The former, like real production workload.
Less than I would like. So not that frequently, maybe a couple of times a year.
But in that case, you probably starting Greenfield, you can pick all the tools you want, you can pick all the platforms you want. It's a completely true Greenfield scenario, correct?
No, that's never happening. That makes no sense.
But that's what Greenfield is for, right? You test out all the new things. It doesn't matter.
It depends how you define, right? So does that mean that I somehow figure out how to literally delete all the experience I have in my brain? Because that would be almost a requirement, right? Because of course that I have certain experience, whatever that experience is, and I'm going to apply that experience on a new project. Now, I will do my best to introduce a new variable to the project, maybe something that I'm not comfortable with and trying out because I'm hoping that it will solve problem in a better way or what's or not, right? But it's definitely never 100% Greenfield, right? It's not that, okay, so I'm running everything in Kubernetes, now let's go and use Nomad. Or I'm writing now in Go, let's do Rust. Now, one of those two is okay, but doing both at the same time would need to be done to qualify it as 100% Greenfield, right? And I'm not doing that, ever.
So what we're doing today is we're going to be taking a look at a post that Ricardo Castro did at the end of February 2024 titled Engineering Success, Prioritize Progress Over Grand Overhauls. Now, we started out with Greenfield because I think there have only been a few times in the computer world where Greenfield has been true Greenfield. Let me see if I'm right on this. So let me see if you catch me or not. We started with mainframes, right? Can we agree that's sort of where computers started? Was
That's where we started, yes. I mean, excluding, what was before mainframes, my brain stopped.
Paper and pencil?
Yeah, okay, that maybe. Yeah, okay, mainframe.
Mainframe, minis, micros, that family of highly centralized compute. And then we moved to, I'm going to say the next big step was client server.
Yeah.
Right? At least from a developer standpoint, when you're working on mainframes or centralized compute, although you may have different languages or anything, all that was pretty much the same, but client server took us in a different world.
Oh yeah, that was a big change.
And then we went from client server to web-based, which was really just a variation of client server.
Exactly.
Right?
Web is still a client. I mean, browser is a client or whatever you're using.
Right. So let's not say web. But now, when we moved back to, I'm going to say Kubernetes is nothing more than mainframe in the 20s.
Yeah. Yeah,
except for the chargebacks, right? Okay, so those to me though, those are the big tectonic shifts, right? Mainframe really started it out. Client server, I'm still going to put web separate because it was a big thinking change.
It was. I mean, the change was not necessarily that we changed from the client server perspective, but more from everything is connected perspective. Like everything is connected.
And then we're at today. So it's basically 4 big chunks. We can argue this all day long. We have the microphone, so please agree with us for right now. And then you can turn us off later. So in this article, what Ricardo's talking about is I'll go ahead and go down the table of contents real quick. The pitfalls of going big, when a big bang might work, which is where I want to live a lot today, embracing the iterative approach, and key practices for successful iterative changes. It's not a very long post. The link to it is down in the episode description. I recommend that you go read it. It'll take you 5-8 minutes at most to read this. So it's a good wrap up of how things work. At least I think so. So here's the pitfalls of going big. So this is like, okay, I'm ready to start working on an application, or maybe I'm getting ready to refactor an application. That was always the fun, right? We're going through a digital transformation. So that means what? Usually we're spending a lot of money with consultants to find out that what we've got is fine. Did I say that out loud?
Yeah. I mean, it's how many companies still work, right? You need to have a project. You need to have beginning and the end. Nothing is worthwhile doing if the end is not far away from the beginning. And you need to start immediately going towards that end. That's how projects work, right? And I haven't read the article, but I'm guessing that that's more or less what he means with Big Bang, right?
That's a good way to think about it. In fact, going right in the beginning of this, we also know that these Big Bang changes more often fizzle out than deliver the promised transformation.
And its explanation is very simple. It ignores the fact that you are likely, or you should, not that you are, you should be learning as you go. Big Bang somehow assumes that you know everything there is to know about something, whatever you're doing, and that the only thing left is to just do it. It's very similar to factories, right? Kind of, okay, so did you design a car? Yes. Okay, now produce thousands and thousands of cars, right? Kind of, you have everything you need, right? And software doesn't work like that.
Wait. Are you saying, against what everybody in the industry tends to say, that software is not like a factory?
Yeah, I mean, I might have met a couple of other people that share that opinion, but yes. Actually, if we would compare it with a factory, and I was always surprised in the past how people made completely wrong comparisons, because let's go back 15 years, because what I'm going to say is easier to explain in that era. We write software and we ship it as CDs, for example, or disks. And we somehow think that factory process is writing that software. The factory process is actually burning those CDs after we wrote the software. Software is the design part. It's not production, it's design. And it happens to take more to design something than to produce it.
We could get into a whole different slew of conversations about that. I'm not going to go there. I want to go through a couple of the points. There's 5 points under this first section. One thing is unforeseen complexity with Big Bang. Here's the problem with Big Bang. I love Big Bang because that means we can just go do it all. But the problem with that is you can't go and just do it all. You don't know all the pieces that are running in your system today.
But that statement is completely false, Darin. Didn't we do the design document before we started Big Bang?
5 years ago we did, yeah.
Exactly, but everything is written over there. There is nothing unforeseen. I don't understand what you're talking about. I mean, everything is planned out. Everything is in Excel sheets. In MS projects. What do you mean unforeseen? Don't be silly.
Well, and we're probably using Visual Source Safe for our source control as well.
Exactly.
It's Microsoft, but that's what it is. Yes, because time moved along. And yes, we had a 5-year design. It took us 5 years to do the design. And now we're ready to go and implement this thing. But all that while during those 5 years, there's been other teams adding new things to this system that we didn't know about, that wasn't factored into that 5-year plan. Big Bang, it can work, but most of the time it's not going to work.
Some teams or companies I've worked with go to the other extreme, and that's of not having the vision. Yeah, so the examples that you were mentioning are actually companies who mistake a vision for the plan or design. A vision could be we're going to go from on-prem to cloud, but that's not the design. That's not the plan. Plan is going to be broken in 1,000 small pieces, right? But if you don't have a vision, if you go to the other extreme and say, okay, let's talk about today's sprint, this week's sprint, and that's all we know, then you're equally going to mess it up just in a completely different way.
One of the other items sort of leans into that. Delayed feedback. With Big Bang, it takes us forever to get to something shipped. It shouldn't take us that long, but because we're choosing to do Big Bang and nobody can see it until it's all done and it's all been painted with 7 coats of paint. And then we rip off the, it's sort of like being at a car show, right? And you rip off the top of it and you find out the car doesn't have an engine and doesn't have wheels, but it's got a great paint job.
Exactly. It looks pretty. What's wrong with it? You'll have another 5 years to make one that has the engine.
Well, maybe not. Last sentence of that point, this can lead to wasted effort, sunk costs, and decreased morale. I just spent 5 years working on this thing. It's never going to see the light of day. It's not what we expected. And now we have nothing.
I would say that more often than not, morale is going to sink long before that. If you're talking about long-term projects like that, people get demoralized if they don't see the result of their work much sooner. Give it weeks, maybe months. If that amount of time passed and you don't see the result of what you're working, but it's just in some ephemeral state nobody can recognize, you're going to get demoralized. I get demoralized.
One more point about Big Bang that I want to look at, where it's not going to work, I guess, is an all or nothing risk. And the point is made when everything changes at once, the potential for failure increases exponentially. Let me state that again. When everything changes at once, the potential for failure increases exponentially. I'm wanting to start creating Teslas on my Toyota production line. How's that going to go?
That's the thing, right? If we make an analogy with the car, it has hundreds or thousands of components, right? And it's enough for one of them with that approach not to work correctly. And you will find it out years later. One destroys everything. Kind of like, oh, everything worked except no steering wheel. And we're not talking about self-driving cars, right? That's the only thing missing. So we did 99% right. It's still complete failure, right?
So are you stating that unless it's 100% complete, it's a failure?
If you go Big Bang, yes. So let's put it this way. What you're doing must be success. Kind of that's how the world works. You must be successful in what you're doing. Now, if I'm not successful, I can try again. But if my iterations are weekly, bi-weekly, maybe monthly, and I failed and I deliver something to production that doesn't work, I just lost a couple of weeks, maybe days if I'm really good at it, right? If you're talking about longer period of time, then yeah, it doesn't work. I just wasted a year. But it either works or it doesn't. Now, when it doesn't work, you adapt, you change, you improve. But the only way for that to make sense if your iterations are relatively short.
Right, but we're not doing iterations, we're doing Big Bang, so we can't do iterations.
Exactly. And it's enough kind of like, okay, so, I don't know, let's say you release something to general public and so it happens that there is no DNS through which you can access it. I mean, this is a ridiculous example, right? But, okay, 99.9% works, it's still 100% failure.
Well, actually, let's say you've got DNS, but nobody's allowed to access it because there's web application firewalls.
Exactly. For whichever reason.
Rejects everything. Yeah. Now, I want to take a look at the next part of this post, talking about when Big Bang might work. But before we do that, let's have a word from today's sponsor. Meet Barbaro Mojo, the delicious Cuban hot sauce with a kick that's sponsoring today's episode. Barbaro Mojo brings the heat with their unique Cuban marinated base, adding an unforgettable flavor to your favorite dishes. With flavors like El Habanero, Halibo, Panazzo, and Best Day Ever, there's a perfect match for everyone's taste buds. As a DevOps Paradox listener, you're entitled to an exclusive 25% discount on your first order. Just visit barbaromojo.com and use the promo code DevOps25, that's DevOps, the number 2 and the number 5 at checkout to claim your discount. Thanks to Barbaro Mojo for sponsoring today's episode. What are scenarios where Big Bang might work?
Never.
Never? Okay, well, no. Let's go through his 4 and decide if never is a true statement.
Okay.
Let me read the 4 first, and then we'll argue or not argue. First one is fundamental tech shifts. The second one is security catastrophes. The third one is strict regulatory deadlines. And the final one is what we started with, Greenfield projects. So let's go back to fundamental tech shifts and think back to our 4 stage of computer life. Whether it's true or false, doesn't matter. That's the scenario we're using. Mm-hmm. We had mainframe, we had client server, we had web, and now we have whatever it is that Kubernetes thinks it's doing.
Mm-hmm.
Those are fundamental tech shifts. Going from mainframe to client server was a big one. Going from client server to containerized or even VMs, whatever that scenario is. Is it worth taking a look at that? Because that might make a change. Let's assume you weren't running a mainframe, like a true mainframe, like where IBM has backed up the bus to your shop and they live there now. But you were running on a micro, a PDP-8, PDP-11. And it's like, okay, now I can go and actually take the code that was running there. Again, arguments are falling apart here really fast. And that became a really nice client server app.
Mm-hmm.
Moving off of the minis and micros to client server.
I see it slightly differently, right? The way I see it is, okay, we have a list of changes we want to do. Maybe that list is we want to change everything, right? Everything, every single piece, right? That's good. That's a vision. But still the question is still the same. What is the piece, the technology or the approach or the process or something that you can change first? It might take you longer when you do numbers in a silly way in the long run, but what is the thing that you can change and apply it to production in a relatively short period of time? Whatever the short period of time, the short can be a year, right? But better than 5. So, I don't know, let's say that you want to move to Kubernetes, right? People will start thinking, okay, so you know what we're going to do? We're going to break the monolith into 57 microservices, and we're going to move it to Kubernetes, and we're going to put service mesh on top of it, and we're going to do GitOps and I don't know what. That's a big bang, right? But that's your destination. You don't have to necessarily do it like that. You can run your monolith in Kubernetes, right? Or you can break your monolith without running it in Kubernetes. And you don't have to break it into 57. You can take one piece of that monolith and say, I have now 2. One huge one, one small one. There are a million ways how you can approach it. But the point is always the same. What is it that I can take and do in a relatively short period of time? And the result will be that working in production without me doing everything. That's the point. If somebody's planning to just do everything and we're going to rewrite from Java to Go and split monolith and run it in Kubernetes and the zillion other things, it simply doesn't work. Or it works, but it might look like a shorter period of time on paper, but it will take longer. At best. At best.
All right, let's move to the next point about security catastrophes. What just came up in my brain on this is we used to think MD5 was a wonderful thing. Some of us did. Until we found out, that's just basically not much better than a base 64. So having a security catastrophe where you leaked all your secrets, or maybe even didn't have your secrets even moderately encrypted. Sometimes you just got to go now. That's the key part, is something terrible has happened. You have to make it happen now.
Yeah, there are those cases. But that's rarely really, those things are happening, but they rarely really require you to redo everything, right? Even in this example, right? I'm not sure how much that counts as Big Bang. In case of security catastrophes, it says encryption to protect sensitive data, right? That's not Big Bang. That's switching your network to encrypted network, right? It might be a lot of work, but it's not Big Bang. Now, if you accumulate things, then it becomes Big Bang.
And I think that's what the scenario is here, is you've accumulated over time and now you've got to do it, which leads into the next point, which is the big one, strict regulatory deadlines. I've been in this scenario in real life to where, hey, there is a new federal guideline that has to be met by this date, which this date is just 3 months from now. And we still have to do everything else too, but we got to add this on top of it. And the way this is phrased well in the end is, there might be no alternative to taking a big swing.
Fair enough. I take my words back. In special cases.
And that's the key point, is how do we tell the difference between a true special case and a special case that we think is a special case?
Yeah, when I guess that you can probably define special cases when you do not have a choice. And when I say you, I mean collective you. I don't mean you as an engineer.
The company has been told this is going to happen.
Yeah, exactly. Your data center just burned down to the ground. Everything goes to cloud. You cannot build a data center fast.
We talked about Greenfield projects. I'm not going to get back into that. There might be a time to do Greenfield, but how many true applications today that you're writing are truly Greenfield? I mean, completely Greenfield.
Depends. If you ask me, and I have no stakes in that company success, then I would do Greenfield all the time, because that's the funniest, the most interesting thing you can do. Hey, if you can give me the language I never worked in and a platform I never saw in my life, and et cetera, I would be a very happy person. But don't do that. This is me ignoring the benefits for the company.
I've said this a few times. If I could go and write software all day that nobody ever uses and I get paid for it and nobody's ever going to see it, that's going to be great. I have no users and I don't even really have to deliver it. I just have to write it. That would be a wonderful job if you could find it.
Exactly. It's like a kid, right? You could change a toy every day.
Let's move out of the sad face of Big Bang. Again, there are real scenarios, especially that you're being mandated by the government or whatever, you've got to do this. Okay, get it. But beyond those special things, at the end of the day too, if you think about it, Big Bang is still iterative because it took you 5 years to write the design document. So that's one iteration. And then you're going to hand it over to development team for 5 years to create it.
Probably the easiest way to distinguish iterative from Big Bang is how many releases to production you have of that grand, mysterious, massive plan, right? If it's one release to production, excluding bug fixes that come later, it's Big Bang. Now, if you say, hey, this 5-year project, but we are releasing to production every 2 weeks, yeah, it's iterative. You just have a vision.
Instead of waiting for the 5th year to ship day one.
Exactly.
If you embrace the iterative approach, this is the next section, controlled risk, early feedback and iteration, what we were just talking about, improved adaptability. The key part there is changing requirements. Do requirements ever change once that document has been minted and printed out on gold paper?
And in this case, requirements, I hope that what he means are both functional and non-functional, right? We can learn that actually we still have time to switch from containers to WASM, right? That wouldn't be a functional requirement. That would be just a technical, something that we discovered in third iteration, right? So not only what it does, but how it's done.
Let's argue the next point. Boosted morale, continuous delivery of value, even if small, fosters a sense of accomplishment. Yes, I'll agree up to that point. I think you'll probably agree to that point. Here's where I think we might differ.
100%.
Yeah, that part is easy. But then the rest of the sentence, and keeps teams motivated. Now, when I read the word teams there, I'm thinking engineering teams. I don't know that's going to keep them motivated. It's going to keep marketing and product motivated because, hey, let's go back to the auto factory example again. You've got the people on the line getting the cars through the shop, out the door, and onto the ships. But then you have the managers up in their offices, up on the third floor of the manufacturing facility, that never step foot on the floor. They're really happy, but the people on the floor have no air conditioning, no heat. It's 110 out in the desert where they're making the cars. Their life is miserable.
If you take that into account, it's not that air conditioner would automatically appear if they would actually not ship it, right? Just produce. I'm not sure that that's a good example, but let's say whatever, the conditions are the same, with or without air conditioning. But the question is, do you ship those cars and do you find out that people like them and buy them? Or do you stockpile them until you reach 10 million cars in somewhere in a hangar and then ship them? And I argue that if I would be producing cars as a factory worker, lowest possible, I would still get some level of satisfaction knowing that this is actually successful, right? Everything else being the equal. Air conditioning equally working or not working, right? My working conditions the same. I would get a certain level of satisfaction knowing that we are actually successful. People want more of that.
When you feel the success, then more than likely you're going to feel confident that your job isn't going to go away. Flip it around. If you're not feeling successful, you may not have a job because the plant isn't producing enough quality that people are actually buying.
Yeah. You're removing, in a way, I mean, you can be increasing at the same time, just to be clear, but generally speaking, you're removing uncertainty. Okay, so actually, I get feedback. I'm doing the right thing. No person died in our cars this month. That's a positive feedback, right? Instead of, we'll find out 5 years from now.
When all the filters and struts have all dry rotted. And then they're released for usage. Yeah. Let's move on to the final section, key practices for success. I'll read the bullets and then we'll talk about them. Break things down. That makes too much sense. Robust testing. Let's talk about that. Feature toggles and strong communication. Actually, let's start with strong communication. And I'm going to break out the auto factory again. If management isn't going down on the floor and talking with the people about what's going on face to face, that's going to be problematic versus if all they're doing is sending emails and posting them in the lunchroom. That's going to be problematic.
And just as importantly, watching what's happening. I'm going to keep the example of cars, right? Are they buying? Are they not buying? Are they complaining about? What are they complaining about, right? That's that iterative approach, right? You get feedback from your real customers. Communication is part of that, right? Because you as a factory worker, you will not necessarily have all that data, right? Because your job is to produce steering wheels, not to do customer interviews. And that's where communication comes in, right? That's what good product managers should be doing, right? They're in constant communication. They should be speaking more with customers than with us. I mean, us engineers, right? They're finding out what we did wrong and communicating it back to us so that we can improve.
That's the key point. As the floor worker, you're not going to be doing those customer interviews because that's not your thing. You're not going to be going out to a dealer. But a manager might be going out to a dealer and figuring out, okay, what's going on? Or they're visiting the insurance companies and saying, what are you guys seeing? Because more than likely, you don't want to do that as the floor person. But that's what the manager loves doing. Now it's just like, okay, how can we close the loop on all of that for both sides of the house? I'm not saying that it's the manager's fault, and I'm not saying it's the floor person's fault. It's both people's fault if things fail. Communication, big deal. Feature toggles, feature flags. Anything to say about that?
You're a fool if not using it. That's what I can say.
It's 2024 already. Start using feature flags. Just do it.
It changes everything, really. It makes it such a big difference.
And we're not saying that you have to go and use a feature flag service, even though you probably should. But a feature flag could be as simple as, again, I'm thinking from a Java perspective, it could just be a system property that is manually set. No web UI. It's just like, I set this. And until I'm ready to do it, it's always this way and I can override it. So I'm testing it out locally, but everybody else is getting the shipped stuff with it off.
Yeah, but then that's usually the beginning, but then we go into slightly more complicated situations where, like Google folks are notorious for that, right? They use feature flags in YouTube all the time. Only 1 million people get to see it without knowing, which is a small sample for them, right? And they measure it and they take feedback through feature flags, right? Because they enabled it to something to a subset of users, hopefully randomly, right? And get feedback. I feel that what feature toggles are to tests is what observability is to performance testing. Yeah, of course, you should test your stuff before moving it to production, and you should do performance testing before moving it to production. But the real measure of whether that's success is observability in production rather than performance testing. And similarly, feature toggles are basically a way how to test things in production. Because you know that you cannot do all the permutations, all the testing. And even if everything technically works, only feature toggles can give you the feedback from the users. Yeah, actually, they simply could not figure it out. They could not find that new button on a page, right? No technical test is going to tell you that. But it is a test nevertheless.
And you're leading into the robust testing. Now, if you go big bang, don't think you can get away from testing. But with iterative, you really need it a whole lot more.
Yes, but you can also, with iterative, you can say that even though I'm not justifying it, saying that you should be doing that. But if you're in a pinch, you can focus on testing that specific thing that you're releasing in this week, right? And you can reduce the scope of tests. Right now, if you talk about 5 years of development before going to production, you need to test absolutely everything. But with smaller iterations, you can actually be more focused. Now, if everything is automated, your tests do not run for days. There is no good excuse not to test everything, right? But if that's not your case, then iterative approach allows you to focus on what you're delivering.
Let me step off here for just a second. Code coverage. You don't have to get 100% code coverage.
Code coverage is one of the silliest things this industry invented.
I want to talk about your unit test statement, though. How long should a good true unit test suite, and this is the key part, true unit test suite, take to run? Like, where do you break glass on a full suite?
Quarter of a minute top.
15 seconds.
15 seconds. And I will give you the good reason for that. I'm a freak about test-driven development. I run tests in the background while I'm writing code. They run whenever I click save. And I have a tick that I'm saving all the time, right? If I'm saving changes every 15 seconds, I realistically shouldn't run tests longer than that. Make it half a minute. Okay, I'm generous today, right? But it shouldn't be like 15 minutes. It defies the purpose. And if that's the case, then you need to figure out a way. How can you, if there is no way around it, if it must run for 15 minutes, then you need to figure out how do you test actually only the things that you changed, which is a valid approach. So what I'm trying to say, whether you run full suite of unit tests or you run unit tests related to what you're working on, which is completely legit, it cannot take long. Otherwise, it defies the purpose. Just to clarify, I'm not talking about tests now that you run in pipelines. That can run longer. I'm talking about while you're coding.
That's what I wanted you to say out loud, is a lot of us still think, and I'm throwing myself in this bucket, tests are for continuous integration, not on my desktop while I am developing.
It's continuous.
If I'm continuously typing, I should be continuously testing.
There is nothing more beautiful to me. I mean, so my workflow is that I have Visual Studio Code. I hate wasting space. Even, the on the left side, you have the files list. Even that is removed. All is split in 2 equal halves. Editor, terminal runs the watcher and just goes all the time. If I don't see red on the right side, I continue. It takes time. It takes effort. It is very frustrating to get there. But once you get there, it's you cannot, at least I cannot imagine not doing it. And I have, to be honest, I have projects which are without tests. And sometimes I feel like, oh man, I don't feel like writing them, right? That happens to me often. But when I get myself to catch up and write the tests for everything, from there on, it's so beautiful. It's so easy. It's so fast.
And that leads into the last point in this section was breaking things down. I'm glad we did this one backwards. It makes more sense. If we can be testing while we're typing, that way when it hits the actual pipeline, you should feel pretty warm and fuzzy about that instead of waiting until the pipeline for it to blow up.
The goal I think that people should strive for is you should never stop working without pushing it to Git. I hate the idea that, okay, I'm just going to leave it on my drive. That's disrespectful to my colleagues, and that's just a horrible idea, right? I don't finish always at the right place. And that's where testing comes in, and that's where feature toggles, feature flags come in, right? I'm confident that, okay, I'm going to stop right now. I feel like my wife is calling me to have lunch. Push to Git, feature toggles, combine with tests, keep it safe. Say, I can push anytime.
Always be pushing to Git. Maybe that's how we should teach everybody to code. Type a character, save, push to Git. Type a character, save, push to Git.
Wouldn't go that far. So it takes kind of like, I push maybe twice a day, but I never finish my work without pushing it.
And by finishing work means you're standing up and stepping away from your desk on purpose.
Yeah, stepping away from my desk. For more than, the only exception is coffee. Kind of, that's like 5 minutes just to get coffee and back. When I'm abroad, in Spain means going to the cafeteria, that's 2 hours. Rest of the world, that's the only exception.
So again, the link to this post is down in the episode description. Go ahead and take a look at it and head over to the Slack workspace, go to the podcast channel, and leave your comments there.
We hope this episode was helpful to you. If you want to discuss it or ask a question, please reach out to us. Our contact information and a link to the Slack workspace are at devopsparadox.com/contact. If you subscribe through Apple Podcast, be sure to leave us a review there. That helps other people discover this podcast. Go sign up right now at devopsparadox.com to receive an email whenever we drop the latest episode. Thank you for listening to DevOps Paradox.